Alrighty, good morning, guys. So we are going to take just a few minutes and review logarithms. That was kind of the topic that I noticed people seem to have the most questions on our work before spring break. So we're not going to spend a whole lot of time on them, just 3 or 4 days, just to make sure you're solid on these. So the first thing that I want to remind you of, logarithms are the inverses of exponents, which means the laws for exponents are going to be very similar to the rules for logarithms. So if you remember with exponents, if we saw two things that were being multiplied, then we added the exponents together. If we saw two things that were being divided, then we subtracted those exponents. And then the last one that people kind of forget is the power rule. If we saw an exponent that was outside parentheses, it got distributed to the whole expression. I don't know why that says whole expression twice there, but I'm going to fix that. But I want you to see how logarithms work in a very similar way. So if I look at number 1 and it says condense. Condense just means to take these two logarithms and put them together into one. Well, let's identify what's happening here. These things are being added. And if I think about my exponent rules, what paired up with addition? Well, it was multiplication. It's just now I'm going backwards. So how do I take these two logarithms and put them into one? Well, if I see an addition symbol, the way that I put logarithms together is by multiplying them. And notice the only two things I multiplied are the x and the y. That log base 3 did not change. It stays exactly the same. What I multiply is the stuff that's inside parentheses there. Okay? Let's say I look at number 2. Number 2 is now going in the opposite direction. It says expand, which means to take this one logarithm and break it apart into two. So again, I identify what's happening here to this 2 and this x. Well, they're being multiplied. So what pairs up with multiplication? Well, addition. So if I then want to break these two things apart, watch what I do here. Okay? I have log base 2 plus log of x. Okay? So log of 2 plus log of x. So anytime you see an addition symbol, the way you put things together is by multiplying. Anytime you see something that's already been multiplied, the way that you break that apart is with addition. Okay? Let's say I look at number 3, and I say, okay, it wants me to condense, so it wants me to put these together. So let's identify what's happening here. Well, in between these two logarithms, there is a subtraction symbol. Well, what does subtraction pair up with in my exponent rules? It pairs up with division. Well, that means then if I want to put these two things together, I'm going to need to divide. Or another way to say that is I need to create a fraction. So watch how I type this out here, because it may look just a little different than you expected. Okay, so I've got my natural log, my parentheses, and because I'm dividing, I'm going to create a fraction, and this fraction is going to be written in the order that these things appear. X plus 2 comes first, so x plus 2 is going to be written on top of the fraction. 3 comes last, so 3 gets written on bottom of the fraction. Notice I didn't try to type anything in my calculator, I just left it as a fraction. Okay? Let's say I look at number 4. Number 4 says expand, and if you look at this 3/4, they're already being divided. So how would I go about breaking those apart into two pieces? Well, division pairs up with subtraction. Okay? So when I expand this, I'm going to have a log base 2 of 3 minus log base 2 of 4. So again, division pairs up with subtraction. Okay? Okay, number 5 is kind of our last exponent slash logarithm rule, and this one is what is referred to as the power rule. So if you notice right here, this 2 is being multiplied or distributed to the whole expression log of 3. Well, what's another way that I could write that, or how could I change that? Well, according to the power rule, it's an exponent that gets distributed to the whole expression, which means this 2 right here that's being distributed to the whole expression can be written as an exponent. So again, watch how I write this. It becomes log base, not just 3, so log of 3 squared. That 2 became an exponent. Well, what is 3 squared? It's just 9. So that one can actually be simplified. The others that we've done so far, you really couldn't. But I know what 3 squared is, so I go ahead and say that that's 9. Okay? Very last one, I'm now going in reverse. This 3 is already an exponent. So if I want to expand it, if I want to make it bigger, what can I do? Well, the power rule tells me that an exponent gets distributed to the whole expression. So I'm going to take that 3 and move it down to the front so that it's distributed to the whole expression. So it's now read as 3 log base 5 of y. And then you're done right there. Okay? Last couple examples that I want to do with you are where we actually just combine these rules together, okay? So I'm just going to do a couple of these examples with you. If you look at number 7, there's a couple things that I should notice right off the bat. First of all, you've got numbers that are in front of these logarithms. Well, my power rule tells me if you've got a number that's being distributed to the whole expression, that's the same thing as having an exponent. So the first thing I'm going to do is just take these numbers that are out front and make them exponents, okay? So that's going to become log base 7 of x squared minus log base 7 of z to the 4th. So notice I did not try to combine that 2 and that 4. Okay, I left the 2 with the x, I left the 4 with the z. Then I have one more step. There's a minus in the middle here. Well, if I remember my exponent rules, subtraction pairs up with division. So my very last step here to put these together, to condense them, is to divide x squared and z to the 4th. Okay? And to do that, I'm going to create a fraction. So I have x squared over z to the 4th, and right there, I'm done. There is nothing else I can do with that expression. Okay? Very last one I'm going to do with you today is number 9. And this one, it's not incredibly difficult, but it has probably been a while since you have seen this. But the first thing I notice that makes this seem a little bit tricky here is I have a square root symbol. Don't let that trip you up, and here is why. Taking the square root of something is the same thing as having that something to the 1/2 power. So watch how I rewrite this expression, okay? The first thing that I'm going to do is I'm going to take away the square root, and I'm going to write it like this. X times y times z to the 1/2 power instead of having a square root there. Well, now I have an exponent up top. Well, I know what I can do with exponents. My power rule tells me that having an exponent is the same thing as distributing it to the whole expression. So my very next step is to take that 1/2 and just drop it down in front of the whole expression, and everything else stays the same. Okay, just like that. And now I'm almost done. My very last step is I'm told to expand this thing. Well, expand means break it apart. Well, I see multiplication symbols here. What does multiplication pair up with? Well, it pairs up with addition. So here's the only difference in number 9. That little 1/2, when I expand this, is going to get written each time. So what I actually have here is 1/2 log base 2 of x plus 1/2 log base 2 of y plus 1/2 log base 2 of z. So I just took those rules step by step. The only thing that was new about number 9 is because I have a square root. A square root is the same thing as having something to the 1/2 power. Okay? And right there, those are your logarithmic properties. That should be plenty to get you started on today's quizzes. Please let me know if you have questions about that.